Okay, last time we have been discussing about the restricted three body problem, and then we started to find out about the Lagrange point, or the what we call as the librational points, where in the synodic reference frame with respect to two primary bodies, one primary body and another secondary body, which are quite heavy with respect to a tertiary body, but which is very small, infinite or say infinitesimally small. So, at the librational point, this tertiary body, it appears to be at rest in the synodic reference frame. Okay. So, we continue with the same discussion in this lecture. Okay. So, we started with the equations. Okay. So, these are the three equations that we started with. So, here for our convenience, we wrote R 1 s is equal to R 1 and R 2 s equivalently as R 2. Okay, and omega s can be replaced as omega. Okay. So, for the integration of these three equations with respect to t, it produced the Jacobi's integral. Okay. So, that we wrote as integration of above three equations produced Jacobi's integral, which we wrote as x dot square plus y dot square plus z dot square is equal to x square plus y square plus 2 1 minus mu star and the left hand side here, this is nothing but v square. So, the same thing we wrote as v square x square y and plus 2 1 minus mu star by r 1 plus by r 2 minus c, and this can be written as 2 u minus c is equal to 5 minus c, where u is equal to 1 by 2 times x square plus y square plus 1 minus mu star by r 1 plus mu star by r 2. Okay. So, here the phi which is appearing. So, phi we wrote as a function of x y z, and for v equal to 0, okay, phi which is a function of x y and z. So, this describes the equation of a surface. So, we will keep discussing about these things. expand it further. So, what we were discussing about the librational points and the or the equilibrium points, which are also called the Lagrange points. So, librational points or the Lagrange points, they arise once we set x double dot y double dot and z double dot equal to 0 and x dot y dot z dot equal to 0 and substitute into these equations, and resulting equations they provide us the librational points. So, we need to solve them. So, also I stated that the librational point, it is nothing but